Hello students. Today we're going to look at partial sums and sigma notation. These are two different things that correspond with sequences. We'll start by looking at partial sums. For the sequence given by a sub 1, a sub 2, a sub 3, a sub 4, all the way up to a sub n, and all the way infinitely long, because sequences are infinitely long, the partial sums are given by the following. S sub 1 is just the first term. This is the first partial sum. It's the first term. The second partial sum is the sum of the first two terms. The third partial sum is the sum of the first three terms. And the nth partial sum is the sum of the first n terms. It's called a partial sum because it's not a sum of all of the elements in the sequence, because that goes on forever. A partial sum is just the sum of the elements of a certain part of the sequence. We're going to be using these later on when we try to take the whole sum of a sequence. We'll try and add up all of the infinitely many terms in a sequence. And there are some situations where we'll be able to do that, and we will be able to get a number which is maybe sounding a little crazy, adding an infinite number of things together. But that is not what we're going to do in this lesson. In this lesson, we're just going to focus on partial sums and getting comfortable with them. So let's look at an example. Find the first four partial sums and the nth partial sum of the following sequence, a sub n equals 1 over 2 to the nth power. We'll start by writing out the first few terms of this sequence so we can get a handle on it. The first term, a sub 1, is going to be 1 over 2 to the first power, which is 1/2. The second term is going to be 1 over 2 to the second power, which is going to be 1/4. The third term is 1 over 2 to the third power, which is 1/8. The fourth term is 1 over 2 to the fourth power, which is 1/16. And we can continue 1/32, 1/64, etc. Let's take a look at the partial sums. The first partial sum is just the first term, which is 1/2. That's pretty easy. Let's look at the second partial sum. The second partial sum is the sum of the first two terms, 1/2 plus 1/4. We need a common denominator here, which is going to be 4. So this becomes 2/4 plus 1/4, which gives us 3/4. So the second partial sum is 3/4. Let's look at the third partial sum. This will be the sum of the first three terms, 1/2 plus 1/4 plus 1/8. We can get a common denominator for all of these, which is 8. And when we rewrite these fractions, we get 4/8 plus 2/8 plus 1/8. And when we add these, we get 7/8 in total. So the third partial sum is 7/8. Let's look at the fourth partial sum, and then hopefully we'll have enough of a pattern to figure out what the nth partial sum is. The fourth partial sum comes from 1/2 plus 1/4 plus 1/8 plus 1/16. The common denominator here is going to be 16. 1/2 is 8/16, 1/4 is 4/16, 1/8 is 2/16, and 1/16 is 1/16. And when we add the numerators here, we end up with 15/16. So if we look at the partial sums, which form a sequence of their own, we get 1/2, 3/4, 7/8, and 15/16. If we want to know what the nth partial sum is, we can look at the numerators and denominators separately. And the key is going to come from the denominators. If you look at the denominators, 2, 4, 8, and 16, these are powers of 2. And so the nth partial sum will have a denominator that is 2 to the nth power. Notice we've got 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and eventually 2 to the nth. Now, if we look at the numerators, we note that each numerator is 1 less than the denominator. 1/2, 3/4, 7/8, 15/16. So to get the numerator, we just need to subtract 1 from the denominator. So here, that's going to be 2 to the nth power minus 1. So the nth partial sum here is given by 2 to the nth power minus 1 all over 2 to the nth power. And having this formula allows us to find all of the future partial sums. If we wanted the 50th partial sum, for example, instead of adding up 50 different fractions, we could simply enter 50 in for n, evaluate this formula, and we would have the 50th partial sum. We're going to be looking at these later when we find the total sum of a sequence, where we try and add up infinitely many numbers, and the formula for the partial sum will be a key tool for doing that. Take a look at some of the example problems linked below so that you can get more comfortable with partial sums and so that you're ready to deal with series when we get to them in a few lessons.